Section 9.4, the hyperbola. So a hyperbola, that's the last conic section we're going to look at, is when you take a plane and you intersect both pieces of the cones at once. And so basically a hyperbola is like a double parabola. It's two parabolas on the same center facing away from each other. And so technically it's the set of all points in a plane such that the absolute value of the differences of the distances from any point on the hyperbola to two given points called the foci is constant. The midpoint of the segment between the foci is the center of the hyperbola. And recall that that center is not going to be actually a value on the hyperbolas, it's just going to give us a reference point. And so just like all the rest of our conics, our center is h and k. And the center is the point from which the graph extends. There we are. Now the center is going to be where our asymptotes cross, and the truth is we're going to have two asymptotes. You'll either get this situation where you have vertical hyperbolas, where you approach the asymptotes on both sides, but your parabolas or your hyperbola is open above and open below. And then the other situation is you have those crossing asymptotes, and you have the hyperbolas being sideways approaching those asymptotes. And so these are the situations that we have going on. Okay? Now, the transverse axis is going to be the line containing the center and the foci or the vertices. And so recognize that our transverse axis is going to be the one that passes through the center and the vertices of the hyperbolas. I really should be centered better over the center. And so recognize that the transverse axis is either going to be vertical or the transverse axis is going to be horizontal, but it's based entirely upon which direction our hyperbola is open. Then to find the foci, we're going to be able to use Pythagorean theorem, that is c squared is equal to a squared plus b squared. And so then let's jump into these standard equations of hyperbolas. It's going to look an awful lot like an ellipse, but different. So, given that hk is at the center, I have this image up here on the right for reference, but recognize that this one is strictly the situation centered at the origin 0, 0, and so we're just going to generalize it. Alright, so hk is at the center, c squared is equal to a squared plus b squared. This is going to open up and down when a squared is under y. Now, what in the world am I talking about? Short version is this. The subtraction, whatever is being subtracted, that's not your transversal axis. And so here we have y minus k quantity squared over a squared minus the x stuff. And so this is a vertical transversal axis. And so let's run through all of our stuff. Our vertices are going to be shift up a distance of a and down a distance of a. And then our foci are going to be shift down a distance of c and up a distance of c from the center. The asymptotes are specifically going to be y minus k is equal to plus or minus a over b times x minus h. And so if you're trying to find the asymptotes, that's how you can find them. And then the transverse axis, because it's a vertical transverse axis, it's going to be x is equal to the x-coordinate of the center, which is h. A horizontal opening hyperbola, well, we have our reference up here in the top right, but that one's specifically centered at the origin 0, 0. It opens left and right when the y stuff is what's being subtracted. And so then a is under x in this situation and b is under y. So recognize that in my two situations, a's and b's are based on which direction do we open. So then our vertices are going to be specifically to the left distance of a and to the right distance of a from our center. Our foci are going to be a left a distance of c and a right a distance of c from our center. And then our asymptotes are going to be y minus k is equal to plus or minus b divided by a times x minus h. So recognize the differences. And then our transverse axis is specifically going to be y equals the y-coordinate of our center, which is k. Alright, so let's start. Given the graph, we want to choose the correct equation. So what do we see? We have a vertically opening hyperbola, which means that it's going to be minus the x stuff, right? And so we know that we're going to have y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. So we know that this is the format, which means we can go ahead and kick out a couple of these, right? Which ones do we know are out? Well, we know this is out. We know that this is out. Okay. So then we've got to figure out which one is correct. Well, recognize that where's our center right here. So notice that 5, 6, 7, 5, negative 6, negative 7 Our vertices are at the points 0, 7 and 0, negative 7, which means that we actually know what A is. Specifically, A must equal 7. Okay? And if A must equal 7, then the only possibility for this equation, because our center is at 0, 0, we know the only choice we have is y squared divided by 49, which is 7 squared. And so that has to be our correct answer. So, let's run through this. So for this hyperbola, 9x squared minus 16y squared is equal to 144. To get it in the nice format, we need to divide everything by 144. So divide by 144, divide each by 144, and we get, and I'm going to go ahead and reduce this, this is then going to be x squared over 16 minus y squared over 9 is equal to 1. If you wanted to finish writing this so you get your a's and b's really quickly, this is x squared over 4 squared minus y squared over 3 squared is equal to 1. So once we have this format, what you need to notice is that we have the x squared minus the y squared stuff. X squared stuff minus y squared stuff. And so since it's minus y squared, the x being the positive stuff tells us that it's horizontally opening. And so we know that we're going to have a hyperbola this way and this way, where of course we have these asymptotes here and here. So they open this way. Alright, great. So then let's find all these pieces of information. Well, where's our center? Well, the center is HK, but in this situation that's 0, 0. And so I know my center is 0, 0. Well, then your transverse axis is going to pass through the vertices and the center. So recognize that in this situation it's horizontal, which means that our transverse axis must be y is equal to 0, which is the y coordinate of the center. Alright, so then our vertices. And so since we know our transverse axis is horizontal, we know that to find our vertices, we go left the distance of A and right the distance of A. So left the distance of 4, negative 4, right the distance of 4 from the center is 4, and so my vertices are negative 4, 0, and 4, 0. Okay. We can find the foci because c squared is equal to a squared plus b squared, and so c squared is going to be equal to 16 plus 9. So c squared is equal to 25. Take the square root of both sides, and we get that c is equal to 5. And so that means my foci, and for the record, center is 0, 0. Foci is 5 to the right and 5 to the left. And so the foci are going to be negative 5, 0, 5, 0. Then lastly, we just need to find the asymptotes. And be a little bit careful because the asymptotes change slightly. It's the difference between b over a or a over b when you're looking at those formulas. And so because we have a horizontally opening hyperbola, our asymptotes are going to be y minus k is equal to plus and minus b over a x minus h. Well, h and k are 0, b is 3, and a is 4. And so then we have that y is equal to plus and minus 3/4 times x. And so specifically one of the asymptotes is y is equal to 3/4 x, and the other one is y is equal to negative 3/4 x. And so those are our asymptotes. If I wanted to be very specific about this graph, I could sketch those asymptotes. So rise over run. And my other one is a slope of negative 3/4. So 1, 2, 3, 4. 1, 2, 3, 4. There we are. Those are the asymptotes. Then, if we want to sketch this hyperbola, it passes through the vertices and approach these asymptotes. They should continue to approach. They should not pull away, so be careful on your sketching. And those are hyperbola. Let's try it again. Here, we're already in the nice format. So we want to find the center, the transverse axis, the vertices, the foci, and the asymptotes, and then we want to graph the hyperbola. First off, recognize that I have y stuff minus the x stuff. Y stuff minus the x stuff means that we have a vertically opening hyperbola. I'm going to go ahead and sketch it to keep myself on track. So, then what's our center? Well, our center is hk, or 4, negative 2. Then we know that our transverse axis has to be a vertical line, so the transverse axis is then x is equal to the x-coordinate of the center, which is 4. Then, if we want, we can just use the grid to help us find everything else. The center being at 4, negative 2, and we know that we open up and down for this hyperbola. The vertices are going to be a distance of 3 above and 3 below. So 1, 2, 3, 1, 2, 3. I do want to change my colors here because these are actually points on the graph. And so red is not actually on the graph, whereas purple is on the graph. Alright, and so that is my vertices are the points 4, 1 and 4, negative 5. Well, it may be a good point to just go ahead and write a is equal to 3 and b is equal to 4, because of course square root of 9 is square root of 16, because then to find the foci, c squared is equal to a squared plus b squared, which is going to be c squared is equal to 9 plus 16. And so I get that c squared is equal to 25. Take the square root of both sides. C is equal to 5. So then my foci are going to be 5 above the center and 5 below the center, here and here. And so the foci are then going to be 4, 3, and 4, negative 7. And then at this point, remember now that our asymptotes are y minus k is equal to plus and minus a divided by b times x minus h. Y plus 2 is equal to plus and minus a divided by b, that's 3/4 x minus 4. And so two equations, y plus 2 is equal to 3/4 x minus 3. And then the other one is y plus 2 is equal to negative 3/4 x plus 3. And so you could add 2 to both sides or subtract 2 from both sides if you wanted. That would be y is equal to 3/4 x minus 5, and y is equal to negative 3/4 x plus 1. Alright, so if we were to graph these asymptotes, y-intercept of 1, down 3, right 4. Notice it goes directly to the center, which is exactly what we intend. And then the other one is y-intercept of negative 5, go up 3, right 4, goes to the center. These are our asymptotes. And then our hyperbola approach those asymptotes in a U-shaped fashion. And so there is that hyperbola. We want to find an equation of hyperbola with vertices 0, negative 4, 0, 4, and foci 0, negative 6, 0, 6. Now in general, I think sketching is a great idea. I'm going to do a very rough sketch. How about? So my vertices are 0, negative 4 and 0, positive 4. Recognize that we went up a distance of 4 and down a distance of 4, which means that we should know what our center is. It's 0, 0, right? But then, if you want, also recognize that we're told the focus, which is at 0, negative 6, and 0, positive 6. And so the center of the foci is again, or the midpoint between the foci is again the center. Alright, so recognize that at this point, I'm just going to sketch this to keep us on track, because if it wraps around the focus, my hyperbola looks something like this. Okay. So, what do we know? We know that it opens vertically, which means that the form we need is y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. We know that our center is the origin 0, 0 because it's the midpoint of the vertices or the midpoint of the foci. Either way, you get 0, 0. Then recognize that we also know what A is. A is the length from the center to a vertice, one of our from the center to a vertex, and so A is equal to 4. We also know what C is because C is the distance from the center to the focus, and that's going to be a distance of 6. We don't know what B is, but we can find B because C squared is equal to A squared plus B squared, and so 6 squared being equal to 4 squared plus B squared, we can solve for B. So that's 36 is equal to 16 plus B squared minus 16 minus 16. So that's 20 is equal to B squared. Take the square root of both sides. We get that B is equal to root 20. At this point, we have literally everything we need to get the correct equation. That's going to be y minus 0 is y. Y squared over A is 4 squared minus x minus 0 is x, quantity squared, over B squared, which we've now found is root 20 squared, is equal to 1. If you wanted to clean this up, you could of course call it y squared divided by 16 minus x squared over 20 is equal to 1. There we are. There's our equation. Now if we're in this format, what do we need to do? Well, of course we need to complete the square. And so let's deal with this. This is going to be 4y squared plus 24y, leave some space, minus x squared plus 4x, leave some space, is equal to, move the constant over, negative 28. Now, we do have to be a little bit careful. And the deal is that we're going to have to factor. And so we're going to do the same thing we did previously. I'm going to factor out the greatest common factor, or the leading coefficient of the squares. And so here I need to factor out a 4. And so when I factor out a 4, what are we going to be left with? Well, we're left with 4y squared divided by 4 is y squared, plus 24 divided by 4 is 6y, leave some space. But here I need to also factor out the coefficient of x squared. That's going to be minus 1. So it's negative 1 times, and here we have to be careful because x squared that was negative divided by negative is x squared, and positive 4 divided by negative is negative 4x, and this is then equal to negative 28. But you must be careful because the coefficients that are being multiplied over here on the left will have to be multiplied over here on the right. Alright, so let's do this. So then we add b over 2 squared, that's going to be 6 over 2 quantity squared, but you got to multiply that by 4, so that's going to be plus 4 times 6 over 2 is 3 squared. Then the next one, we need to add b over 2, which is negative 4 over 2 quantity squared, but that's going to be negative 4 divided by 2 times negative, so that's going to be negative 2 squared, and so that's going to be negative 4 divided by 2 is negative 2 squared. And so then what do we have? Well, this now factors. So this is 4 times y plus 3 quantity squared minus x minus 2 quantity squared is equal to negative 28 plus 4 times 3 squared, 4 times 9, or 36, minus negative 2 squared, but that's just going to be 4. And so I get that this is 4. And so then I can divide everything by 4. Divide by 4. Divide by 4. I then get that this is y plus 3 quantity squared minus x minus 2 quantity squared over 4 is equal to 1. And so recognize this y plus 3 quantity squared is over what? Well, specifically it's over 1 squared. And so we got 1 over here. And so then if you want a real quick, you could rewrite this one last time. This is y plus 3 quantity squared over 1 squared minus x minus 2 quantity squared over 2 squared is all equal to 1. Okay? So then recognize that our center is at 2, negative 3. And so 2, negative 3 is our center. And then for our vertices, we just need to go, well, the y stuff is what's not being subtracted, so we know that this is actually going to open vertically, and so it's going to open up and down. And so if I go from the center and I go up a distance of A, which is 1, and down a distance of A, which is 1, I then get my vertices. And so the vertices are then going to be 2, -2, and 2, -4. If we're trying to find the foci, well, we need to find C. So we know that C squared is equal to A squared plus B squared, which means that C squared is equal to 1 squared plus 2 squared, or C squared is equal to 1 plus 4. So C squared is equal to 5. So C is equal to the square root of 5. And so then I just need to go up a distance of root 5 and down a distance of root 5 from the center. And so my foci are then going to be 2, -3 plus root 5, and 2, -3 minus root 5. Then our asymptotes are going to occur at y minus k is equal to plus and minus a over b times x minus h. And so that's going to be y plus 3 is equal to plus minus 1/2 x minus 2. So two asymptotes, y plus 3 is equal to 1/2 x minus 1. And the other one is y plus 3 is equal to -1/2 x plus 1. I can subtract 3 from both sides and I can get y is equal to 1/2 x minus 4. And y is equal to -1/2 x minus 2. And so those are my asymptotes. If I want my graph to be accurate, I can sketch that -4 and then go up 1 and right 2. One asymptote. The other one crosses at -2 in the center. And so there's my asymptotes, which means my hyperbola passes through the vertex and approaches the asymptotes. And remember, I shouldn't be pulling away from those asymptotes. I should be moving closer to them, but this is a sketch. We do the best we can. And there we are. That's our hyperbola. I forgot to mention the transverse axis, but recognize that it opens vertically. And so this is going to be the transverse axis is x equals the x-coordinate of the vertex. Alright, so let's try it with this hyperbola. Same idea, we're just going to have to complete the square first. So this is 4x squared minus 24x, leave some space, minus 25y squared. There's no other y stuff, so this is then just equal to 64. But then do be careful because we do have to factor out the leading coefficient, and so this is going to be 4 times, well, factoring out that 4 leaves us with x squared minus 6x, leave some space, minus 25y squared is equal to 64. Well, then I add b over 2 squared, which is -6 over 2 squared. But over here, it's going to be plus 4 times that, because of course it's 4 times this on the left side, so 4 times -6 over 2 quantity squared. And so then this factors as 4 times x minus 3 quantity squared minus 25y squared is equal to -6 divided by 2 is -3. -3 quantity squared is 9. 9 times 4 is 36. 36 plus 64 gives us 100. Then I can divide everything by 100. We then get that this is x minus 3 quantity squared divided by 25 minus y squared divided by 4 is equal to 1. Alright, notice that A is 5, B is 2, and our center is specifically 3, 0. And so since our center is 3, 0, the transverse axis, well, that's just going to be, recognize that the x stuff is not being subtracted, and so this opens horizontally. And so keep myself on track, it opens this way. And so my transverse axis is y is equal to 0. Then let's mark my center, and then we can find the foci. So since the center is 3, 0, and my transverse axis is horizontal, I know that to find my vertices, I just go to the right a distance of 5, 1, 2, 3, 4, 5, and to the left a distance of 5, 1, 2, 3, 4, 5. And so then I know that my vertices are specifically -2, 0, and 8, 0. Then my foci, I just need to find what c is. So c squared is equal to a squared plus b squared, and so c squared is going to be equal to 25 plus 4. So c squared is equal to 29. So c is equal to root 29. And so my foci are going to be 3 minus root 29, 0, and 3 plus root 29, 0. And then lastly, where are our asymptotes? So for a horizontal opening, our asymptotes are y minus k is equal to plus and minus b divided by a times x minus h. And so I'm just going to move up here, finish that algebra. And so this is y minus 0 is equal to plus minus b is 2, a is 5, 2/5, x minus 3. And so we get y is equal to 2/5 x minus 6/5, and y is equal to 2/5 negative 2/5 x plus 6/5. And so there's our asymptotes. But honestly, since we know our center mark, you can just use the center mark and move from there, because of course if we've done this correctly, our asymptotes will pass through there, and use our slope from there. So 2/5 here, here, and then down to 1, 2, right 5, up to left 5. And so then our hyperbola look like this. And we're done.